this is Mary for Team Big Hero 6, and welcome to our presentation on our application called Diet App. For our project, we wanted to make an application to help people, especially those with medical conditions, be able to choose what meals they want to eat. We made a web application that allows users to create an account and input their health information data, or choose from a set of sample patients to receive meal recommendations either for home or from hospital, or receive local restaurant recommendations. For a little bit of background on the problem that we're trying to solve, it can be very difficult and overwhelming to choose what to eat, especially if there are many considerations that need to be taken into account. Many people are often left with having an unsustainable relationship with food, diets, and with managing their chronic health conditions. Our project is attempting to fill the gap in the current market of nutrition apps, as most focus on calorie and macronutrient tracking and not with meal recommendations, especially not with restaurant recommendations. Our application integrates React.js for the front end and Java Spring Boot for the back end, storing information using a MySQL database for user account information, health information, and meal information storage. Meal recommendations are based on the user's health data, including their allergies, health conditions, dietary preferences, and medications.
Hi everyone. So my name is Shreya. I'm going to talk about the research we did throughout the project. So for this project, we did several research to make sure that our system aligns with the healthcare standards and provides meal recommendations that meets the user's health needs. So the first thing we focused on was understanding the FIRE system, specifically the FIRE nutrition order. It is important because it helps to capture patient diet preference, which are the key for creating personalized meal recommendations. We look into its documentation to ensure we are able to create meal recommendation based on the specific health conditions, such as diabetes. We also explore the FIRE sandbox server to retrieve real world patient data through the FIRE. This is an important part of our system as it ensured our recommendation were based on the actual patient information. In addition, we explore the several public APIs and datasets. For example, we use the Yelp API to find restaurants that offers meal that meets specific dietary preference, like vegan, vegetarian options. So we also used the USDA Food Data Central API to gather nutritional information for a variety of foods, which allows us to ensure the meal recommendations were aligned with the user's health needs. Moreover, we also did research on hospital meal guidelines for patients with specific medical conditions. Furthermore, we explored how medication affects dietary recommendations, and this to ensure our meal options supported patients' treatment plans and improved their health outcomes. So, however, during our research, we ran into a few gaps that impact the implementation of our project. So the first is the hospital meals. So we're struggle to find actual hospital meal database that includes the necessary nutrition information to create the actual meal plans for the patient. And without this data, it was hard to provide meal recommendation for inpatients. However, we find a way to work this around. So we developed a sample hospital meal API that simulate meal options. but this has limitations. The recommendation algorithm could only have limited meal options, so it could not address more complex or personalized dietary needs. Similarly, when it came to restaurant recommendation, we could not find the data sets with detailed nutrition information for each restaurant dishes. This missing data made it difficult to offer truly personalized meal recommendations based on the nutrition needs um, of each patient. As But however, we also to come up with a solution. So we allow the users to search for restaurant by specific uh, preference. For example, the users can input keywords like vegan or gluten-free. Well, this helps in some of degree, but it did not provide the detailed nutrition breakdowns as we wanted.
Hello, everyone. Welcome to our diet recommendation application of our team. Upon the first opening the app, the user will have the selection to log in manually or log in via Fire. I will first demo the login um, via the manual way. So for login, first of all, for first-time users, they will have to sign up for an account. Let's sign up for an account using a username and password. So I would do Larry Tran. Passwords also Riley Tran. Passwords can be pretty much anything, also username. Sign up. Upon clicking sign up, the user will next have to populate their user profile. So let me fill in these fields. All right, these are some sample date of birth. And for a city, I will do Orlando, and state is Florida. Just a heads up for users, please only put in the city with one word in order to get the Yep API search to work properly. All right, I will go ahead and select, for example, allergies diary, low carb diet preference. I will go with diabetes for this patient or user. So the associate medication is metformin, diabetes, and the patient will be an inpatient. Save profile. So the user will then get redirected to the dashboard where they can view their user profile. So what they just entered earlier. Yep, they can view everything here. And let's get to the meal recommendation, which is the core functionality of the app. So first glance, you can see that the user have access to both home and hospital meals because the user is an inpatient. Um, First of all, we have this toggle for strict search, and strict search means that if you click on get recommendation, the system will try to find meals that have the text set that strictly match the full text set of the user health profile. Okay, let's try strict search for this user. Okay, for right near, you can see that there's no meals found. So please try turning off strict search. So we allow the fallback recommendation. Maybe there's no meals in the database that would fully match or strictly match the user's health profile. So let's start dropping tags in a priority queue. It would first drop the diet preference and then the medication and then allergy, but it would never drop the health condition. So now click on the get recommendation, and just as you can see, it does return back some meals, and it has to drop these three tags in the user tag set, and it was using just diabetes to grab these two meals for the home meal. So you can click on view details to view more about the meal information and see that it's tagged diabetes. Again, for the second meal, these are the tags that belong to that meal, and it does have the diabetes tag. Okay, let's do the same thing for hospital. So let's try strict search. All right, also no meals found. So let's try to toggle to disable the strict search, and we do get back some meals. 3 meals here for hospital meals, that the same logic with trying to match the user's health profile. Okay, let's get back to our dashboard. And for restaurant recommendation, it is pulling the user's location, which is Orlando in Florida. And first of all, the user will see all restaurants in that area, in that city. We can filter out or search, put in some, select some predefined search terms like vegan, and let's do the search again. So it would apply the vegan search term together with the location and output this list of restaurants, which are the vegan options. Again, we can try for vegetarian, and yep. And then we can try for gluten-free as well. And yep, no restaurants found that are gluten-free in, the city specified in the user profile. Okay, let's go back to our dashboard and let's log out so that we can demo the login via Fire flow. So login via Fire means that the user will select a patient from a predefined list of Fire patients. So let's try to log in as An Nguyen, and let's log in. So as you can see, you don't have to populate any user profile. All of the user profile information has been pulled automatically from that user's electronic health record from Fire. Yep, so everything has been filled in, and this patient is an inpatient. So let's get to the same meal recommendation. Because the user is an inpatient, so again, they have access to home meal, hospital meals, and also restaurants recommendation. We can try for home search, strict search, and yep, nothing's get back. So again, you can toggle the strict search as needed for each type of the meal. Let's get back to the dashboard, and again, we can take a look again at the restaurants, recommendation. So same logic from with the manual user way. All right, so we can try maybe another Fire patient. I would do an outpatient this time. So let's try Miss Maria Smith. And let's take a look at Maria Smith's user profile. So she is indeed an outpatient. So something that I want to point out is if you can now go to meal recommendations, you see that she only has access to the home meals and restaurants recommendations because she is outpatient. Only inpatient has access to all 3 types of meals. Okay, let's get back to your dashboard and you can log out and, redo any login flow that you would like. And thank you. That's all for the demo.
Hi, let's go ahead and talk about the future work. So if we were to continue development, we would start by integrating Smart on Fire to improve authentication and security. We would also connect to real Fire servers containing actual patient data to enhance the accuracy and usefulness of our meal recommendations. Expanding support to multiple hospitals would allow for more diverse patient profiles and dietary needs. We also plan to upgrade our Yelp API integration so users can receive restaurant suggestions based on real-time filters from their health data instead of a fixed set of search terms. Further research is needed to explore a wider range of real patient profiles using the FHIR standard, as our current sandbox data lacks the completeness that we wanted to have. We would also need to investigate improved nutrition data sources such as the USDA API, which we could not implement this time because of the team constraints and due to time constraints. Additional development would allow us to focus on expanding our condition and medication support beyond the initial chronic illnesses. We would also want to automate more of the health data analysis so that it can reduce the manual user input. In the future, the project could scale into a full-featured health assist platform used across hospitals, clinics, and at home. Beyond clinical use, this app could serve fitness communities, elderly care, or users with lifestyle diets like keto, vegan, or gluten-free, and they would all be tailored to their personal health profiles.